The Dow Corning America's Technical Manual provides some recommendations for good sealant joint construction practices. This is an example of a conventional moving weather seal. We have a case of good joint design on the left, and in contrast, a case of poor joint design on the right. Key points of the good design include that dimension A is at least 1/4 of an inch, dimension B is at least 1/8 of an inch, and dimension C is at least 1/4 of an inch. Dimension A needs to be at least 1/4 of an inch because sealant is going to allow movement based on a percentage of the sealant joint width. Dimension B needs to be at least 1/8 of an inch so that the sealant material doesn't tear when the joint moves. And dimension C needs to be at least 1/4 of an inch so that it can adhere to the substrate. If dimension C is less than 1/4 of an inch, it will be possible for the sealant to lose the bond to one or the other substrates as the joint moves. Maintaining at least 1/4 inch of sealant bite at the substrate is absolutely necessary to ensure a long-term seal. The recommendation is to have a ratio of A to B of at least 2:1. And this allows the tension at the substrate to be less than otherwise. If the joint ratio were less than 2:1, the tension at the substrate would be greater. So having a 2:1 ratio minimizes the tension. It's necessary to tool the joint surface. When the sealant flows out of the gun, it is placed into the joint. The tooling agitates the sealant and causes it to flow into the pores of the substrate. So you're going to achieve much better adhesion to the substrate when you tool the joint. Note that the suggested maximum dimension for B is 1/2 inch. Sealant does not need to be any thicker than 1/2 inch to create a watertight seal. In general, you want to never exceed 1/2 inch of thickness. It extends the cure time. When the sealant is that thick at its midpoint, it's going to exert more tension on the substrate. The sealant could be less than 1/2 inch and be watertight. Note that the maximum dimension for A is 4 inches. It's not recommended to create sealant joints more than 4 inches wide. If the joint is wider than 2 inches, you may need to apply sealant more than one time in order to create an aesthetically pleasing result. When your joint size exceeds 2 inches, it's very difficult to create a nice smooth joint in one application of sealant. In contrast to the good joint design, the poor joint design exhibits a deep sealant joint. And this is not going to result in the desired movement capability because the sealant is so thick that it's going to oppose movement, and our ratio between A and B, it's not good. We're going to put a lot of tension on the substrates. We're increasing the likelihood of joint failure because when we put that much tension on the substrate, we expect that the sealant will pull away from the substrate. We've also created a condition where the cure time is going to be much greater because of the sealant's excessive depth. We have examples of a moving corner joint design. Notice in our good joint design that dimensions A and B are both at least 1/4 of an inch. This means we have a pretty big joint here. This isn't just a little strip of sealant in the corner. This is a large joint. We're creating a bridge of sealant with a little bit of length to it so that it can stretch. In contrast to the poor joint design, a bond breaker is used, which again allows the sealant to stretch. In contrast to the poor joint design, the good joint design is tooled. It could be tooled flat or it could be tooled so that it's a little bit concave. In both cases, we're creating a thinner cross-section of sealant, and that's going to reduce tension at the substrate, which gives us a better, longer lasting bond to the substrate. In our good joint design, dimension C, which is the sealant bite, it's at least 1/4 of an inch. In contrast, our poor joint design has dimensions A and dimensions B at 1/4 inch or less. You can't maintain a seal when you don't have the proper sealant bite. We have to give the sealant an opportunity to bond to the substrate. It needs to be at least 1/4 of an inch in order to create a long-term seal. Notice also that our poor joint design does not use a bond breaker, and therefore the joint will not accept movement. When movement does occur, the sealant will lose adhesion to one or the other substrate. Recommendations for remedial joints. The good joint design is characterized by dimension A being at least 1/4 of an inch. Again, this is the sealant bite, the contact area with the substrate. Dimension B, the thickness of the sealant must be at least 1/8 of an inch. Bond breaker tape is used to isolate new sealant from old sealant, and the bond breaker tape allows joint movement. If existing sealant has not lost adhesion to the substrate, you want to remove it before applying the sealant in that same area. Now you can seal over, you don't necessarily have to remove all of the failed sealant, but in the area where we're creating a bond with new sealant to substrate, we need to make sure that that area is totally clear of old sealant. Now, our poor joint design is characterized by dimension A, the sealant bite, being less than 1/4 of an inch. That's not a good way to create a seal. We have to have at least 1/4 inch of sealant bite to the substrate. Dimension B, when that's less than 1/8 of an inch, it increases the likelihood of pinholes or voids in the sealant joint and results in poor cohesive integrity. So the sealant is likely to tear when the joint moves. Also, no bond breaker material is used, and that is going to prevent the joint from accepting movement. Recommendations for splice joints. Hopefully, you're getting the idea. You can once again see that our good joint design is characterized by a minimum 1/4 inch sealant bite. The bond area to the substrate is at least 1/4 inch. Our good joint design is characterized by bond breaker tape and a minimum 1/8 inch of sealant thickness across the width of the joint. An alternative good joint design includes the use of an aluminum splice plate. Notice also that adhesive foam tape is provided in conjunction with bond breaker tape. The adhesive foam tape creates a space between the bond breaker tape in the face of the panel. This increases the sealant bite. You can see that sealant is not only bonded to the edges of the panels, but it also bonds to the face of the panels in the cavity created between the adhesive foam tape and the bond breaker tape. In contrast, our pour joint design constrains the sealant bite to only the edges of the panels. Finally, we have a recommendation for the best splice joint design. The best joint design incorporates greater sealant bite and the use of a preformed silicone membrane. We also have recommendations for cap bead glazing joints. Our good joint design is characterized once again by a minimum 1/4 inch sealant bite. Notice also that the joint width is a minimum 1/4 inch. Recall that the moving joint required the 2-to-1 ratio. Here we have closer to a 1-to-1 ratio. We're using a completely different sealant material. We're going to be using different types of sealant to create these different types of joints. In contrast to the recommended design, the pour design does not allow sufficient sealant bite. As the pour design illustrates, we would expect the sealant to pull away from the frame substrate, and the joint will prematurely fail, allowing water to enter into the glazing system. Achieving a 1/4 inch of sealant bite to the glass and the frame is absolutely necessary to provide a long-term seal. We also have examples for window perimeter joints. At this point, it should be obvious to you that our good joint design includes a minimum 1/4 inch of sealant bite to both substrates. Our pour joint design is characterized by an insufficient amount of sealant bite to the window substrate. Because we failed to achieve in the pour joint design the minimum adhesion, we expect the sealant to pull away from the window substrate and that joint to fail prematurely.